Okay, so we're here on notes 10.1, and first of all we're going to look at just our radicals, and the difference here is square root of 5 and square root of 36 is 5 is a decimal, it rounds to 2.24, whereas 36 goes into 6. 6 times 6 is 36. And so the difference is that square root of 36 is a perfect square, and so perfect square is something whole number square root. And so if you look down your page, we have the first 15 squares. If you need to pause for a minute and copy this in. And so just every number, for 1, 4, 9, 16, 25. These are ones that, if you are familiar with them, will make it much easier going through this unit. But if not, you'll still be able to come back and look at this page of your notes. So then moving on down the page, this is just an example of how square roots work. So we have square root of 12, which if you write that in, that comes out to about 3.5. And then there's problems that say 3 square root of 5. So square root, remember, means a number multiplied by itself to get to 5. So the square root of 5 is decimal. 3 is the whole number. If we wanted to move this back in and write it as an unsimplified square root, it would become square root of 45, because 3 squared is 9, and there's already a 5 under the radical. So what we did is we took this 3, we square it to make it 3 times 3 times 5 inside the radical. So if something outside is going inside, we have to square it, because that's the opposite of square root. This isn't something you usually do in math. Usually we simplify. But if we did this, 2 outside, if we're going inside the square root, becomes 2 times 2 times 5. Which, if we're expanding it like that, would become square root of 20. 3, if we're going inside, would become 3 times 3 times 2, which is square root of 18. So that's just to help you kind of understand how this works. What you are asked to do in math very often is simplify. So when we simplify, we have to say what perfect square is in there that we can pull out. So there's 2 ways you can do this. We can take 45 and write out all the factors. So we have 1 and 45. 2 does not go into 45. We have 3 and 15. We have 4 does not go into 45. We have 5 goes into 45 9 times. 6 doesn't go into it, 7 doesn't go into it. Those are all the ways to multiply to 45. And then we look, are any of these perfect squares? So this one's a perfect square, 9 is a perfect square. That lets me know that I have square root of 5, square root of 9, inside the square root thing here. I can solve square root of 9. I know that square root of 9 equals 3, and so I can write this as 3 root 5. And if you've recognized already, that's the opposite of what we did here. We took the 45 and worked back. And the second way to solve it, which some people find a lot easier if you don't know your perfect squares easily, you can just take 45 and just draw a factor tree. So 45 divided by 5 is 9. 9 divided 9 goes to 3 and 3. And anytime you have the doubles, they get to go outside of our square root box. The doubles is what moves it outside to just 1, 3. And so that becomes, the doubles become 3 outside, root 5 inside. And so you can choose your favorite method. I usually choose the factor tree, so that starting with my smallest number, so that becomes 2 and 25. 25 is 5 and 5. Those are my doubles, so I'm left with 5. 2 is left over. Doubles move outside, singles stay inside. 125, so I divide by 5 and 25, and 5 and 5 again. Or if you just recognize that square root of 25 is 5. So my doubles move outside, I'm left with 1, 5 still inside. 72, so I divide first of all by 2, that gives me 36. 36 is one of my perfect squares, so I can divide it out into 6 and 6. Or if you don't recognize that, you can do something different and divide it down. So we have our 6 and 6 double, and so that gives us 6 root 2. Now, if you decided to keep moving that down, and you don't have, if this confuses you, you don't have to do this. But say I did 72, 2 and 36, and then I did 2 and 18, then 2 and 9, then 3 and 3. I'm still left with doubles here. I just have two sets of doubles now. And so when I have two sets of doubles, I have 2 times 3, and then I'm still left with a root 2. And I always multiply anything. If I have two numbers on the outside or two numbers on the inside, I multiply them to give me the 6 root 2. So go ahead then and flip to the next page. So when we multiply radicals, it's just like multiplying when we have algebra. You multiply your whole numbers, we multiply the variables. And so that gives us 6x squared. So we multiply the like terms. And so when we are dealing with square roots, it's the same thing. We have square root 5, root 6. We just multiply them together to get root 30. Very important, keep your root symbol. Square root of 30, if we check it in the calculator, equals 5.47. That's very different than a whole number 30. So if you leave the square root symbol off, you're talking about something completely different, and so you can't do that. When we multiply these, same thing. We multiply 3 times 8, that's 24. We make sure to keep our square root symbol. Now with both of these, we always have to check, see can they simplify. So 30 just divides down to 5 and 6, like we just multiplied, and then 6 goes to 2 and 3. There's no doubles, so it can't simplify. This one does divide down, so 24, 3 and 8. 8 does divide down farther to 2 and 4. You might recognize that perfect square already. That goes to 2 and 2. That's our doubles. So our doubles go outside, keep our square root symbol, and then we have a 2 and a 3 left over that we multiply inside to get 2 root 6. So 2 root 6 is the same as root 24, but it's a simplified form. Just like we always reduce fractions, we always simplify our square roots. On 8, we have numbers outside and inside, so we just multiply our outside numbers to get 30, multiply our inside numbers to get root 14, and 14 just divides down to 7 and 2. So this is just 7 and 2, which doesn't simplify anymore, so it can't simplify. Alright, next we again multiply our outside numbers, our whole numbers, multiply our inside numbers. 48. We go ahead and break down to 2 and 24. We recognize now we have the rest of the factor tree for 24 already there. So 3 and 8, 2 and 4, 2 and 2. And so we have the double 2's there. And here we actually have another set of double 2's because we had the extra 2 for 48. And so that gives me the negative 10 still on the outside. And my first set of 2's comes out. My second set of 2's comes out. And 3 is left by itself inside. And then I multiply all of those to get negative 40 root 3. Alright, next one. 2 negatives makes a positive, so that gives me 48 root 4. Hopefully by now you recognize that 4 is that perfect square of 2, and so that gives me 48 times 2, which is 96. Whole number. That completely simplifies, no radicals left. Here, and I'm sorry, I wrote over that, this is a squared. Square root of 5 squared is just 5. If you want to see the math of that, I do square root of 5 times square root of 5 gives me root 25, which then I break back down to 5 and 5, which become the whole number. That square root, if that's all that's there, the square root and squared cancel each other out. Now in problem 12, we have the square root and squared. Those are going to cancel each other out, but we still have 3 that needs to be squared. So if I expand this out, this becomes 3 root 2 times 3 root 2. I multiplied my 3's, or I could from here just straight do 3 squared. That gives me 9 root 4, and of course, the 4 simplifies to 2, so I have 18. Alright, 13. First step, we multiply straight across. So 3 times 14 is 42, and 7 times 27 is 189. Now, and that's of course both in the square root symbol. Now this is actually one that we can reduce. And so this is kind of a challenge problem. I'm going to show you the steps, but first of all we're going to divide 42 out into its prime factors. So that's 2 and 21, 3 and 7. And so I'm going to just go ahead and write it out that way. So 42 is 3 times 2 times 7. And then 189. 2 does not go into it, so I do 3 and 63. Then 3 again and 21. And there's that same 3 and 7. And I'm going to write that out as 3 times 3 times 3 times 7. So when I have it broken down into prime factors, this is just an easy way to reduce when you don't have your fancy graphing calculators that reduce for you. I cross out the ones that are the same on the top and bottom. And so then that gives me square root of 2 left on the top. I have my double 3's on the bottom that I can move out. So that becomes over 3. We could also see if we can reduce before. Sometimes that works. I could do the 14 divided by 7 beforehand, 3 divided by 27, and multiply them that way. If you like shortcuts, that's an option. Alright, and last example, we multiply straight across. It gives me square root of 5 over square root of 36. Hopefully by now you recognize square root of 36 is 6. And so my answer is square root of 5 over 6.